Hello everyone. I'll just look up correct window, which is not here. Yeah, this window is the correct one. So, today I'll talk about geocoding API that I have written for our clients, which is very simple, very bare bones. Yeah. The idea is to have a service that can be used as check address autocompleter when you are buying something online in a shop. You'd probably like to have the address written correctly so that the package arrives on the right place, because mistakes are common. We are only human, so it's good to have something that helps you. Why? There is already an awesome game called Geocoder. Why wouldn't we just use this game? The gem is awesome, but not all the APIs it uses. There is Google API, which is the default, but as far as I know, the API's license requires you to use it only with map. I don't know, I don't want to have my map in eShop for delivery address. I know how it looks where I live. There's no reason to have map there. And there is second obstacle. The license only allows to use it on public pages, not on the internet sites and so on. To live these limitations, you have to have paid account. Without the key, there should be a quota more than 2,000 requests in 24 hours or 5 requests per second, which is not enough for autocomplete, because in autocomplete you usually need about 2 requests per second for single client, but may be good for checking the address in backend, because, for example, our business system processes about 200 addresses per day, which is not very much. I'm not sure how the quota is implemented in Google's APIs, but it seems to be sort of stochastic fairness. So it even in a system which is only processing 5 addresses a day, we not every day, but several times a week we get over quota error, even if we are just querying the API 5 times a day, which is not really good. So let's see how those APIs are working. Google is default geocoder, so we can do something like geocode without any switches. Let's see. Now it's working. When I tried this before the start of the talk, I got the over quota error on my first request from this IP address today. It seems like kindly broken quota algorithm, but it is the reality. So the list of APIs supported by Geocoder game is on its GitHub pages, and it's really huge. But I only tested a few more APIs, namely those that are not requiring any API key, because from my viewpoint, it's much more simpler to be able to use API without key, at least for testing purposes. So the first one is nominatim, which works pretty good. Let's see. Nominatim is pretty good, but the quota is 1 request per second, which is not good for autocompleter. Data are partially incomplete. Notably, as we can see, many check addresses don't include postal code, which is really necessary for delivery. I have also tested OVI, which are maps from Nokia. It worked, but now seems to be dead. Let's see. For example, this is my address. Connection can be established. Even the API endpoint is dead. So there are few self-hosted options to be reconsidered. First one is called Pelias.io. It seems to be promising. It's based on Elasticsearch, but it seems to me a bit complicated to set up for the first time. So I'm planning to have a look at it later, because Elasticsearch is somewhat like good decision to start something which is based on searching. And there is also something called Data Science Toolkit. And geocoding is not the main focus on the project, but it has a killer feature. It has Google-style geocoder, which is designed to take the same arguments and return the same data. So it might be good idea to look at the Data Science Toolkit as well. But I still decided to make my own API because I wanted something that would work well for Czech addresses. And I wanted something to be open source, and I wanted a possibility to self-host the API, and I wanted to have it as simple as possible. Why to have it built as a separate project with API? It's useful in multiple applications, and the data set, while relatively compact, it's less than half a gig. It's probably too big to bundle with applications themselves. So the data are available from Czech Statistics Institute. There is an URL. And data are updated on monthly basis, so the new buildings should be there pretty quickly, which is another problem with most of the publicly available APIs. Sometimes it takes several months or even years to have all the new buildings there. And the nice thing is that all the addresses have unique ID, so that, for example, last year, if you know the village or behind Prague called Vestec, they have a new post office there, so that all addresses changed. The only change was the postcode number, but if you have unique ID of the address and you have updated data, then you can do it for all your customers from like your position, which is really nice to update the addresses of the customers if something changed like the postcode number. So this is a nice feature of this data source. So I wrote a bunch of Ruby and Bash scripts to download the data, to pre-process them, and to load them to SQL database. The scripts are available at this GitHub project. You can give it a try. On my laptop, it takes like 5 to 10 minutes to download the data, process them, and put them to database. And now let's see some code. I have to like adjust the window so that you can see at least something. What folder should I click? Who knows? App. In fact, all the smart, or not really smart things are in model, which is called address, and we have method called autocomplete, which works on address model and joins cities, postcodes, and city parks and streets. I'm really glad that this little method gets to Rails recently, because auto-joins are really useful and they were not available otherwise than handwritten in later in older Rails. And I'm just processing the term that someone writes in. I'm splitting it by comma, and each part is processed separately so that you can. So it joins words of like street. If you have street like u dobré vody, then it's processed in single step. And if you have city with more than like one word, like city dobrá voda, for example, then it's second part. And I take all the numbers. If the number is 5 digits long, then it's certainly postcode, because for some reason all the numbers are less than 10,000 in Czech Republic, so it's pretty easy to tell if it's the number of a house or if it's postcode. And all the words can be streets or cities or city parks. So there are a few more helper methods, and let's see how it works. Give me an address. And some number.
5.
It's not working.
There you go.
Yeah, it's working, but yeah, it is working, but it took some time. So we have seen the code, we have seen like simple demo. When now you can use it, it's already like on the internet, on the api.geocode.cz. If you are interested, you can use it. I'll just show the JSON form of the data. There is a really simple README, and I can click on the. So this is the autocompleter like backend, which takes some term and returns possible addresses, possible matches, and this is just single address because for some reason I have only added coordinates to single address API. This doesn't have coordinates. It's an error, but coordinates are available. Maybe it's good to note that these coordinates are in so-called JSTK format, which is very smart. It's Czech specialty because the coordinates are in meters. So if you can measure that distance from one place to another by using very simple math with the square root of differences to the power of 2. So I probably will add conversion to WGS84 coordinates in future, but I didn't need it so far because our customers are using this simple distance measuring for the moment. And that's it. What's next? There are some issues. For example, it is still too slow. the results are not sorted, and there is big potential in caching because the data are changing only once a month. So it should have like expires header with the next date and time of the update. And we have the issues already here somewhere. No. Issues are here. Issues are here. Here you can add your own issues if you want, or you can take the issues which are already there and try to fix them. I'd be really glad. So that's probably yeah, just a little note. I also intend to add that simple high availability because the data are immutable. They are only changing once a month, so it's pretty simple to add high availability to this kind of project. But that's it. If you have any questions, ask them, or you can catch me later at the bar. Thank you for your attention. Is there anyone who would like to use my API? No one.
We would like to try it. We'll try.
You will try? Thank you. So that's it? No questions? Ah.
Why haven't you used the official database of all addresses and entities UIR or the US or UIAN?
I think it's the same data set. Maybe
yeah,
in
you can just get all data in one package where you have like all entities and
I think it's really the same data set. It's a zip file with some like several thousand of CSV files. There was an XML version somewhere, but it disappeared from the internet during last year.
It seems the same.
Yeah. Okay. Yeah.
And when I saw the joins for each query, is the one of the pitfalls there. Did you think about the place table is probably the biggest one there? Like querying the table with some full text from Postgres.
Yeah. I try to repeat the questions. The query question. It was the first issue is too slow. Maybe you should try to like get rid of the joins and maybe use full text indexes which are available, for example, in Postgres database. Yep, this is one possible route, but I definitely wanted to try Postgres as well, just to see how it performs, because when I started, I used like queries with MySQL, and then I found that MySQL is really stupid about like queries. So I rewrote the part of querying of number, because there is no use to use like for numbers, because numbers can be rewritten like set queries or between queries. And it took like 2 seconds before with like, and with those in or between queries, it is usually less than 100 milliseconds. So it became usable, and at this point I stopped further optimizations, and I decided that I'd like to show the project to others, and maybe someone who already did some kind of optimization will help me.
Okay, so please welcome Honza.
So, hello. Did you hear me well? Yep. Cool. So, good evening. My name is Honza,
if anyone were on the last grills, sorry, who were there, probably remember my talk. I'm from EMAN. I am front-end and back-end team leader there, so I have few people in team and I take care about them. Actually, we also have newly created developers Twitter. No hiring, just an information we are sharing, like great stuff, not just from Ruby on Rails world. So you can follow us. And some information about me. Actually, I mentioned the first one. I also work for University of West Bohemia in Department of Computer Science, and I have 6 years now in Ruby on Rails world. I'm a big fan of Node.js also, and sometimes I am open source contributor. So straight to the topic, my presentation will be in 4 parts. First was the long way to clean code. To be clear, what we do, you need to know some basic information. We are working with financial and other time series data for a while, and we have one big problem, and the problem is we have multiple sources. It means that we are not enough with one SQL query and one fetch. We have really multiple SQL queries to just present one data table with few charts. We are thinking about some BI tool. Who knows something about business intelligence too knows there are some OLTP and OLAP cubes, but for us it's not useful because we are allowing to users to change basic conditions how the cubes were created. So that was not the way, and we are using Ruby. When we are working with it, we evolve few stages. I try it to explain the stages by some examples. So imagine you are on the student's flat and you have some girl visitor. If you are on student's flat, it probably looks like some kind of that. Now you have few options. Besides, if your flat or if your apartment looks like that, it will be much better to take her in some nice restaurant. But we can work what we have. Obviously, you can risk it and don't quit at all. That was our first implementation. We just grabbed multiple sources of the data and let them in the active record objects. And in views, we are trying to convert them, calculate with them, compare them, create totals for the data tables. It was the first prototype, and it works for some time, for a really, really short time. So the stage 2 is you put all your stuff on your bed. Who never does that, actually? A lot of programmers does that. And for us, it means we didn't start with the active record objects. We mapped them into another object, and by overriding plus equal operator, we get the results. It works better, really better. The code was also better, but it wasn't what we want, actually. There were there were some potential smell. So we moved to the stage 3. You just put blanket of your bed storage to hide all of this stuff under your bed. Again, in our implementation, it means we just create one cool object. We map all data in this kind of objects, and just work as well in the stage 2, so compare them, override plus equal operator, and we get the results. The solution works for like year, maybe. It was bad. Everyone knows that. It was the notorious monster under your bed. So we think about that a lot of hours spent on what we will do with that, and we were forced to do that because some, you know, your boss give it your task to do more with what you have, and we have to add next data source. It was like horrible because the code complexity increased a lot. We have to write like a lot of duct taping. It was not good, and we always know we really want something like this. We actually, this for us means n-dimensional data cubes. And when I choose this picture, I didn't even notice there, but actually on the picture is one data cube also, because of the drawers under the bed. That's the data for you. I have to explain what data cubes actually are. If you want to do something with data representation, you start with point, it can be variable, whatever. Then you think about it, I want more of them, so you create an arrays. That's cool, works. Now you think about it and you need more and more, so matrices, arrays of arrays, and then you stuck with cubes. Or, in our way, n-dimensional cubes. They are really hard to imagine. Actually, you can't. You can imagine one cube, or you can imagine if you add some time or whatever, you can imagine some kind of what's on the picture. As you can see, that cube can be in financial word like cost on the one x, profit or revenues on the other x, some data variables on the long x or watt, time, whatever. And now we have an idea what we want. So the challenge was how to implement it. We won't implement it like a standalone library because we don't need to tie it up with our code, that's nonsense. And I hope we will someday put it like an open source library, it will be really nice. And actually there are two priorities for us. The cubes will be fast enough, that's obvious, and some Ruby way how to do that. The cube must be fast enough, and if you talk about how it fast will be, you need to think about how you store the data. N-dimensional cubes, n-dimensional arrays. Why not? There's a problem with creating them if you have like 8 dimensions, it's normal for us to have 8 dimensions and 8 dimensions, but if you create an array of an array of an array, it's not fast enough. There's a lot of problems how to do that, and you really need to create it before you start using it, because you can't have empty spaces there. Because empty spaces means nil check, perform nil check for each operation you do with the cube. No. But there's one advantage, and it's faster access. We take a different way, one-dimensional array, I think everyone knows that you can access to or store in one-dimensional array matrices. That's completely normal. There is some kind of equation how to calculate index for matrix in the one-dimensional array. If you continue with the equation, you just, okay, you can use it for 3 dimensions, 4 dimensions, n dimensions. The equation is so general, so you can calculate everything. Computing indexes seems like to be a pitfall for our implementation, but it's not. Actually, it's benefit. I will show you on the next slide why is it benefit. And copy faster aggregation while rotating the cubes. You just one point of view on the cube is not enough, so you need aggregate them, rotating them. And anyone here knows there is a product function on array? Do you know about that? Anyone use that? The function is to generate permutations of what you provide from one array to another array. It just creates not permutation, combinations. And actually we are using it because if you go deep enough, you just see that's a relation between indexes and the data store on each X. So you can pre-calculate these indexes, and if you are doing some aggregations like sum, or I don't know, you want to remove one X, you can use it because you know it where the data are actually. We are using proxies. Proxies was really useful. Who never used proxy, try that once actually in your implementation. And we are using them for virtual slicing to access the real data or to access the axis. And that's why the computing of index of the element you actually want, it's better, because if you are using proxies, you just remember the last step, or you add more and more and more, if you like, go deeper and deeper for the data. We actually override the hash operators to be the library more Ruby feeling. I can show you on the example. I hope it's kind of readable. We didn't use integers like indexes. We create some kind of hashes because it's more readable in the code. So we create one cube with 2 axes, price, cost and revenues, what, with what and without what. It's like standard cube for, no, it's matrix right now. You can fill it with zeros, why not? And if you access to X with what, you just return proxy cube with reference to the original cube. So you don't copy the data, you just remember I access with what, X call what. It's cool, and from that you just compute the target index and you can set the values there. So the results for us, we decrease code complexity a lot, really a lot. We have clean, nice views finally. We create nice charts. We actually create tooltips where the data came from, actually from which data source, really fast. New resources, no problem for us now, in minutes. Speed, also better, why not? Computation in views, decrease. And thanks to Ruby and how powerful Ruby is, just 345 lines of code. So thank you for your attention, and now some questions, and I hope I will be able to answer you. We have 15 minutes, I think we have time. So, no questions, that's weird always. So, you always, or we always have these data in memory, always. But in our first and second and third way of implementation, we actually have this data in separate objects. So the result memory will decrease. Yeah, it fits. We have like 32 gigabytes of RAM, so it fits. Yeah.
Like what's calculated within the cube and what's calculated in SQL? For example, for filtering.
Filtering, we left filtering on the SQL, and we are trying to, actually everyone knows that you have data table, big nice data table, and you have the worst button on data table ever is order. So if it can be done, we are trying to let the databases to order the data. But in most cases, we are ordering the cube itself. Yeah, because we have multiple data sources, and even if you are order by all the data and you set them in the cube, the totals from it or some axis totals can be different than what came from database. So conditions, database, ordering manually.
So correct me if I'm wrong, but the cube you are using is mostly used for presentation rather than like basic calculation.
Yeah. Yeah. Mostly for presentation, but if you want just like a total, like in the table foot, we are doing it also in Ruby, not on the database, because it can be done actually for the data we have. It will be really like a lot of if statements in database queries, and we still need the information where the data came from. And I can imagine if you have if statement in database, you don't know if it's this column or this column. Yeah, the basic example is if the data column is bigger than today, use price 1, and if it's today, use price 2 in some aggregation. So you have result what you want, you can like fill the table, but you don't how you get where the data came from the column A, column B. You will just need to iterate the database again. Yeah.
You mentioned in the title that financial services would be a use case for this. Are there other use cases you've already thought of?
Yes, we are using it mostly for financial data, that's true, but with time series and other use cases. I don't really know why you won't be able to use it like standard OLTP cubes normal. So if you like working with, you have the data from your employees when they came to work on Sunday or whatever, you can use it as well. It's up to you. Anyone? Okay?
Is your cube ready for non-time series data?
Yes, you can do whatever you want with the axis. But probably like sum by 1x will be harder. You can use you don't have to use big decimals or floats or numbers. You can use your objects. That's like the basic of Ruby. But you need to override the plus equal operator if you want to sum something. Okay? Anyone else? Or we just stop it and cool. So you will see me again in a few minutes.
So, thanks, Hunter.
Okay, so hi again, I'm Daniel. I'm from Showmax from the backend team where I take care of the Ruby development. And today I'd like to share with you the experience we made with microservices and in particular nesting. Why nesting? Like in the beginning it seems to us as a good idea to include responses of other services into others. But it turned out actually not. And now let me just show why. So, microservices. What does it mean in this context, microservices? It means the data is scattered around various places, right? So it's not all sitting in one place being served on one API endpoint. It's sitting on various places. On the other hand, we have this kind of guide that says that the APIs should be built to be easily consumable. So if we combine these things together, what arose from that? What arose from that? Let me show on the example user list. As you probably know, we're a VOD business, so we're serving videos, user watch the videos, and we store these videos into something called recently watched. It's the list of the assets, we call them assets, that you have seen, watched. And it's kept in the user list here. But for the clients to be able to render the user lists to the user, they need also the asset metadata, like the poster, the picture of the asset, the title of the asset, like Game of Thrones, and some nice, catchy picture from that. And this data sits in CMS. So we said, okay, let's be nice to the clients so they can only make one call to get the data. So the response from the user list looks something like that. You don't really need to be able to read that, but let me just show you that the user list stores only that much of data, and the rest, which in fact is 200 lines of code, sits in the CMS. Well, it was working nice, clients were happy, but after some time, the backend stopped to be happy. It wasn't really performing. So we took JMeter, we ran simple performance tests on 20 threads, and ignore the table on the top right now, and just look here. The Rubysty doesn't really look great now. It does like 24 requests per second. You can see 50% of them are even errors. So it's like 10 requests per second. That's not much, right? So here you can see the same data on the graph. So the red line shows the actual responses from the user list, and the pink line shows the responses from Varnish, which sits in front of all our APIs. So we can read two pieces of information from that. The one piece of information is that the latency of the calls was that high that the health checks from Varnish weren't actually failing, and Varnish was considering the backend as sick and stopped routing the traffic from that. And the other piece of information is that if Varnish was serving the 503s that fast, the actual throughput was even lower than 10 requests per second. Yeah, so what about that, right? So the solution was kind of easy. Let's drop the nested data. But first we needed to find out if it's really the cause. So we added profiling, pretty simple. Ruby block that takes the time, then yields, and that takes the time again, puts it into logger. We added that into the code, and soon we saw in the logging that it really is the nested calls that takes the most time. So we knew what to attack. Also, they were limiting the throughput because we use Puma, and as you probably know, Puma uses threads. Puma is a thread-based server. Let's drop the process parts now. That basically means that each thread is blocked by a request until the request is finished. So in other words, it means that until the request is finished, it doesn't serve any other request. So that many requests you have, if the request is 1 second, you will be able to serve so many requests as you have threads. Yeah, so it was easy. So we dropped the nested calls, bumped it, published as new API version, and the only thing left to do was for the clients to actually take up the API version, which seemed pretty easy, right? It would look something like, yeah, that. So the client would make the call to the user list, get the IDs, with the IDs, call the CMS, and get the metadata. So the response from the user list would be only the top 20 lines of the response, of the original response. Hippie, let's make the clients build a new API version. It turned out not to be as easy as we originally thought. Especially the mobile clients were concerned it's going to be slow. So let's say let's be feeling driven, let's be data driven. So we made them make the measurements, and it turned out it was slow, which doesn't surprise anyone, right? So the whole thing was put on hold until we launched in Poland. Launch in Poland wasn't especially pleasant thing. The one thing that turned out that not only the nested requests slowed down their service, they were also consuming quite huge amounts of the resources. So they actually fried the servers, and the other services that were running on the same cluster didn't get to the CPU. But the positive thing was that we finally had the firepower to convince the clients to adopt the API version. First, they had to overcome the problem with the slowness, so what they did, they implemented client-side caching. So the users would actually be only affected the first time they fetch the SF data, because SF data rarely changes, in fact, almost never, so you can cache it for 2 years and you're happy. This actually finally happened. You can see the measurements without the nested responses. You can see no errors there, and 5 times greater throughput, which was pretty good. There are also other advantages of that. For example, with original implementation, if you're resending data of other services, you obviously also have to add up the API to support the same parameters that as the nested service does. And if the nested service changes, you have to change your service as well, which is something we don't want to do. Here you can see the same data in the graph. Now here's an example of another service. This is user profile, so giving the user data. Again, microservices, user data spread among several services. So we have user profile, billing, author authentication, and again, user profile was doing the same, returning the data from all the other services. So here you can see latency. So in the green line, it's the old API version, and you can see the latency like 400 milliseconds. And when we drop the request, it's like 7 milliseconds, which is a great difference, right? Yeah, so that was it. I was faster than I thought. So yeah, again, Daniel from Showmax. Do you have any questions?
Actually,
yeah, come.
I don't get it about when you create version 2 API with this feature, and you just explain the goals. You create 3 vectors.
Yes.
Because first on the
Standardizing?
Then there is like data.
Okay.
We think about it and just build some kind of GraphQL proxy in front of them. You have it. You have it. Or
GraphQL proxy. We don't have GraphQL in the backend. That's one of the things that frontend actually. They built a pure frontend GraphQL version to be able to gather data from them. you have like correct point. There are two approaches to website test. We can build like the layer in front of that, like the Classics. We can gather the data and return them back to the client. And there is our backup plan, because in case it's something more demanding, time demanding, resource demanding. But we were able to get away with this, which is much more faster, simpler. So, thanks. Yeah. Any other questions?
So that solved all the problems in the end?
All the problems in the universe. No, it was just one of the things that we actually did to help us scale. And here are the others. It was, yeah, the scaling is a nice thing, like no plan survived the first contact with the enemy, I mean users. So, yeah, so these are the other things. And some of them are pretty nice to actually mitigate or meet. So please come and grab me over back here, I'll be sitting over there, and I'll be happy to chat to you. Okay, so thanks again.
So the last thing happening today before grilling is the debate about performance in Ruby on Rails. There will be Honza talking about it, but you are welcome to join and share your opinion and everything you want to share. I don't know whether there will be someone from Showmax here as well. Daniel, do you want to stay here for the debate?
Debate. Right now?
Yeah. Because we have two chairs, so. Chceš něco chceš mikrofon nebo ne? Nechce mikrofon. Okay. So the grill is heated already, so there will be burgers later. Don't miss them. Zima je venku. Question. I think there will be some yeah. So please, it's yours.
So the next is just like an idea what to do next. I'm just quite sick of it. Then if I talk with someone, why don't do Ruby or Ruby on Rails? The answer is Ruby is too slow. Yeah, I think everyone who works with Ruby on Rails, that's the classic response from Node.js developers.
Wait, you mean like 10 requests per second isn't enough?
Yeah, for everyone. I tried. I have a few topics of conversation, and so actually I always just like, if it's someone interested in about Ruby performance, I suggest you to follow or to look about these 4 people and actually look for RubyCon presentation. The first who don't know about Mats is the author of Ruby. Koichi is a guy who stands behind Ruby 3.3. I'm not sure why it's still adopting Steam. I don't bother. No. Aaron Patterson, guy who works for
It's not the Rails core team.
He works for Heroku. He works in Heroku and he's fully paid to work on Ruby and IRB or MRI interpret. Nate Burkopek, guy who has a Ruby performance guide, cool book for $2. And definitely watch them on RubyCon. and RubyCon itself, the biggest event about Ruby. So, a lot of topics about Ruby 3.3. Don't know if you heard about that. Who didn't heard about Ruby 3.3? 3 times 3. No. They try to make version 3 times faster than version 2. And there are several approaches. What they want to do first is JIT, just-in-time compiler. It helps V8 and Node a lot. Java also profits from JIT. Who didn't heard about Gemalog? Okay, so if you try that, definitely try that sometimes. Ruby has allocation procedure how it allocates memory. And it's not so good, so you are able to compile your version or Ruby version with with external allocers. It's library around malloc to allocate memory with less fragmentation. It's a cool library. A lot of performance tests is around. We are using it with.
So let me ask a question meanwhile. So when it prevents the fragmentation and perhaps a silly question. So we listen to footprint, right? Does it also help the performance time-wise to fetch the objects actually faster?
Yes, because the time to search them is smaller. I don't know how to explain it. Actually, never was.
So I don't know how they are addressed. So
yeah.
But in practice, it is.
It's faster. For some reason, the memory footprint is smaller and the MRI is faster.
Okay.
Next thing is to use wrong libraries to standard tasks. I don't know if someone use here Great API. We didn't try that sometimes. It's fascinating. It's really fast. It's faster than Rails actually itself. And you
can I add to that?
Yes.
We use Greek. We love it. And obviously sometimes we came to the same point. Ruby is too slow. And so we took plain Goliath server and then we made the measurements. And then we added the grade. I don't know the numbers off the top of my head, but it was something like 3 times slower just with the plain input. So we still upgrade, we still use it, but I think there are still ways to optimize. Like we ended up somewhere inside the requires of active support and caching and stuff like that. So some of the libraries are predicting performance even better than it is. She is, yeah.
Is that I think then we plan to change it. Or the Hashinas currently and C implementation. Not really sure. But great. We love to use Grade because of the validation.
Yeah.
It's like the alpha omega. If you work with multiple teams, they consume your API and they sending also data is the best way because they are immediately alerts. They send something very bad.
The custom validators are great.
Yeah.
The only thing is the URL validation doesn't propagate into nested grapes. So if you include the grapes and the nest, then it doesn't propagate itself.
We actually have some similar issue that we want to describe with Swagger. We have a cool library, use Great with Swagger. To describe the road parameters, and they have big issues with it.
How long did it actually take you to make the Swagger? Oh, it wasn't Swagger. Sorry, it was the
Not using profilers. Whoever use profilers or production profilers, it's kind of like Neuralink, the best one. It's quite. It's not cheap. Neuralink. It's 30 days. From web server configuration, really interesting article, how to proper configure Puma. Because someone or also people thinks, okay, it's slow, so just add threads or processes. It doesn't work like that. It can be worse and worse. There is some kind of equation how to set it properly and get the maximum from your hardware.
Can you give an example?
What?
Can you give an example of a configuration?
It's on the page actually. Just
Like
copy the
5 threads maximum. That's the point of the. Unless you're using Geo.
whoever uses JRuby.
Not all of them, but one service where we really need the parallelism.
Okay. And are you satisfied with it?
Yeah. Well, it was painful in the beginning, of course. Like what's the curve name? The learning curve was pretty steep.
We have some big issues to migrate existing application into JRuby.
We didn't have issues with the application itself, but with the gems.
Yeah.
You run into gems written in C.
Oh. That's not.
So now we could like in JRuby don't use OJ but we use JC.
For debugging, we are changing to Ruby just to debug and then just changing back to the
There is one very useful gem with great performance, and the author are debugging or profiling on JRuby. You know what's the library? It's Sidekick. The author just really tune that stuff up on JRuby because Java has much better profilers and not upgrading Ruby Rails, etc. Completely now. You're stuck with like 1.9.3 Ruby. You can't expect any big performance.
What connects to that, when we upgraded to the recurrent, we got into it 25% slower.
Which version to which?
It was 4.1 to 4.2.
Some new features.
Yeah.
Raw data storage for specific data. We have we've been requested to create something called application log, and we have just Postgres there, so we create a table with a lot of columns, weird data types like block and text, and in a few months the table has I think 4.6 million records. If you have normal R table, no problem. 4.6, no problem at all. But if you have logs, tags, it was really slow, so we migrate the data into Elasticsearch. Not just for the full text, but the performance was like from minutes in seconds or less. So to use the proper storages for proper data, it's all fun, oh my god. Everything, even if the boss wants to just try to convince him, it's great, like no caching, that's common issue. Who cache? Who cache? A lot. Actually, in some, when I speak with new candidates in interviews, I ask them, do you know what's a Russian caching doll pattern? Russian caching doll. You know what it is? It's the basic, it's caching pattern in standard Ruby on Rails. There's one cache, and in that you have another cache, you can expand it. It's like the Russian dolls.
anyone can join at some point. It was like,
or anyone else's package adds to the Elasticsearch. We have logs in Elasticsearch, so all the services are revealed to Elasticsearch, and we're able to show process the request per day, and you're still having the like 30 days of the logs available in the Veleba, so we are able to search them like with a click of a button. It's really amazing.
5 seconds. Oh. You have like 5 seconds per question. How long they go?
empty.
Yeah.
But probably you are using beats or log slash to gather the data. You are on Elasticsearch presentation last part, and the data introduced beats. That's so cool. Actually, it is because it's like really small than log slash. One server to use to run log slash.
So for Ruby 3x3, does that mean that we're just going to wait forever for Ruby 3?
I hope not. Actually, there is, I'm not sure it's not Twitch, but one guy actually will support Ruby, contributed to Ruby. They create one new branch with Git actually. He almost finished it. Not Git. So I hope 1 year. It will be really nice sometimes, like just like Rails test and don't wait. I don't go to make a tea or coffee when the tests finish. Also, the information is about that. There was a talk with in CAD to Ruby code in Japan. It was great.
I think of the last year or two, months, like promised some kind of deadline.
What everyone else wants to deadline.
Yeah, the deadline is actually broken, right?
Do you have something specific to say about generally?
I tried it once actually, and I tried it like a home project, but one specific thing was for the project necessary, and it was multi-language support. And in that time, they didn't support multi-language projects, so I tried it once for like 10 minutes. It was nice, really, but then I had to switch to Sinatra and finish the project there. Actually, I can indeed. I made it and but then I see the deadline and no time to try something new. It was great vision. I really loved it. I'll try that.
Do you have an idea how does Veleba do performance-wise compared to others?
What performance on what?
That's good. Well, doesn't mean much. Let's start.
Okay. For like, I don't know, like full stack solution.
I'm actually, I'm
Just have a certain breath. It's really hard to hear. Please speak up.
okay. Try that. Actually, Rails is the problem. They just implement next and more features. So the stack must be slower and slower because the array is not faster and faster. But on the last feature in 5.2, I am very happy, and it's active storage. No more paper clips or carrier waves, and this new implementation will help the person pick up. We are using it like everyone else, but
This API kit, have you looked at it?
Rails API.
The active search.
Yeah. I tried that in one project, but it's still in beta. And in the project I have 5.1, so I just write the version and I stuck with it. It can compile because other gems in the application won't be able to run. So don't try that with at all. I read the documentation about it, but I still waiting to prepare some libraries. But it's cleaner than paper. Maybe one point more to use async processing. Don't calculate on the main threads. It's like one more thing. Don't generate PDFs in main threads. Don't generate Excels in main threads. Actually, if you generate Excels, you probably use AXLX. Don't use it. It's very memory. We actually have a problem. We have no memory on the server, like every day, and we are looking for some memory leaks, and we stuck with the AXLSX gem consumes like 2 gigabytes of memory for 200 bytes of data. So.
You ever run JRuby?
No.
Yeah, 2 gigabytes is
Not yet, it's Java.
Yeah.
Do you have some alternative for the spreadsheets?
As Fast Excel.
How?
Fast Excel. It's a library which is just like a native binding to libexcel, classic Linux library to create Excels, and it's faster and it's smaller, memory footprint is lesser, but AXLX, the original library, provides like, I think it provides charts and etc. A lot of functions, but if you just need some exports with some tables for customer, Fast Excel is better.
how big Excel was you created from this channel?
Just to clear this, how is it fast Excel or fast Excel?
Fast Excel.
Yeah.
Like, did you created some Excel with like 200k lines?
No, I think AXLX won't be able to do that until you have 200 gigabytes of RAM.
I just remember some problems with Excel in some BI systems with these big Excels. Even created as like in separate threads, but like, they had the problems with it.
They have like one big issue in this library, and it's memory consumption, and fixed memory consumption of this gem, and it can't be done because each cell is an object, so you can't fix that, and that's the reason why it consumes memory a lot. So don't use it.
So
try to avoid it.
It's holding whole file in memory at the time. Yeah. Okay.
There's no way to stream?
What?
Is there no way to stream it?
I'm actually not sure if they support it now. We just like drop it, and we don't want to hear about it because it was a big source of pain to debug and to be sure it's not a memory leak. Did you ever try to some of you to debug or look for memory leaks?
Only in Java.
Major.
In C.
Yeah, in C.
Yeah,
there's Valgrind.
So in C is like default option for the
If you look for it, it's really interesting how to do that. You know, there's a RB trace full library production ready. You can just inject into running process, and thanks to Ruby 2.0 or 2.1, you are able to dump whole object space. So you start your application and dump the object space first. Then you wait for some time and you dump it again. And after a few hours, when the consumption is bigger and bigger, you dump it again. And you're just looking for the objects which was in the second part or from the second dump and not in the first one, because it was allocated between them, and you just look for the libraries or resource allocation for a few days to figure it out where's the problem. And this task can be huge. So you can end it, or anyone else?
I just have a general question, because I'm in Ruby and Rails like for the half a year, so I don't have enough experience. But what is Hanami?
No, it's library. You know what's Sinatra?
No.
Okay, there is more ways how to create web pages in Ruby.
Yeah.
The well-known is Rails. I think one of the oldest ones is Sinatra, and Hanami is new project. They try to be the same like Rails, but as functions. So we can end it probably.
Let's go for food.
Yeah.
Thanks.